this is one thing that is not really one of my favorite things to do. It is something that some people do have a struggle with. It is kind of on your homework, and you have done it before, not in here, but you have done it in a previous grade. It's a measurement conversion. You're going from one unit to another unit. Like if I asked you how many inches are in a foot, 12. So if you have 1 foot equals 12 inches, that's a measurement conversion. You're going from 1 unit, feet, to inches. That's going from 1 unit to another. So here we're going to do it again, but we're going to be doing it with fractions. So if you know how to do fractions, that's one thing. If you know how to do a measurement conversion, that would be another. And then you have to kind of do them together. Once you figure out how to do it, that's the tricky part. Okay, so we're going to do the first one, and probably the second, and probably the third. We're going to do them together, okay? So I want you to look at, I'm going to do this one just basic, okay? We're going to do this without any fractions at all. If I have 3 gallons, 3 gallons, and I want to know how many quarts that is. If I look at this, I have 3 gallons, and I want to know how many quarts that is. The first thing you want to think about, now before you start yelling at me what the answer is, that's not what I'm asking. I'm not asking for the answer. If I know, what information do I need to know in order to solve it? What do you need to know first, Jacoby? How many quarts are in a gallon? I need to know that here, that I've got 1 gallon is equal to 4 quarts. You need to know that. So I've got 1 gallon is equal to 4 quarts. You have to know that. So if I've got 1 gallon here is equal to 4, how many gallons do I have in this problem? How many do I have?
12.
How many gallons do I have? I don't have 12 gallons. I have 3. See, you are not answering what I was asking. I didn't say how many quarts. I said how many gallons. So if this is 1 gallon, I have 4 quarts, but I have 3 gallons. Now, why did you give me 12? What would you do to get 12?
3 times 4.
3 times 4. So because when I'm going from a big unit to a small unit, you're supposed to multiply. Now, there's a little hand gesture that one of my students, I learned things from students, believe it or not. If you're going big to small, multiply. I had never seen that before in my life until last year. And I was like, oh, that's so cool. And so then small to big, divide. So your face kind of becomes little dots. So small to big, you divide. So, but you have to kind of know which one's the big and which one's the small. If you don't know that a gallon is bigger than a quart, well, then we kind of have a problem. So I need to take 3 times the 4. 3 times 4. So then you have 12 quarts. Okay. So what do I do if I have 3 1/4 gallon? And I want to know how many quarts that is. If I have 3 1/4. Okay. do I do it any differently? Am I still going to multiply?
Yes.
Okay, so what I want you to do is I want you to work this in your group because you still work it the same. Sheldon, if you want to sit at a different table, that's fine because you're kind of sitting on your own. Unless you want to work it by yourself, that's fine. So if he wants to sit on his own, so I'm going to give you just maybe about 30 seconds. It's not going to take that long. So I want you to work on this problem, and then you're going to tell me what the answer is. Okay. If you got 13 quarts, you are correct. I'm going to show you, there are 2 different ways that you could solve this problem and still get 13. You were close. You just forgot one thing. Okay. So we know that in 1 gallon, you have 4 quarts. So you're having to change the gallon to 4 quarts. So it's 3 1/4 times 4. So when you multiply a mixed fraction by a whole number, this is one of the ways that you can do it. Like I said, this is one of those things that it's been a while since you've done it, so if you forgot how to do it, that's okay. Whole number times the whole number, 12. Whole number times the numerator, 4 fourths. When the numerator and the denominator are the same, it's equal to 1. So 12 4/4 is equal to 13. So you just forgot to multiply that. Okay, so that's the one way that you could solve it. The other way that you could solve it is to turn this into an improper fraction. And this would be 4 times 3 is 12, plus 1 is 13 fourths. And then multiply it by 4. You have to make it 4 over 1, obviously. Straight across. 13 times 4, that's 12, 52. And see, this ends up being more work doing it this way. Over 4. Oops. 4 into 52. 4 goes into 5 once, but is it wrong?
No.
No. Goes once. Right? Either way, you still get 13. It's not wrong either way. You still get 13. Okay. Okay. Let's try another one. Let's try 2 5/6 of a foot into yards. What do we know about feet and yards? Serena, what do we know about feet and yards? So I have 3 feet equal 1 yard. So you need to be careful because what does my chart say over there? Or with our hand motions? We're going, what's bigger? We have to divide. Have I taught you how to divide fractions yet?
No.
Have I taught you how to divide fractions yet?
No.
No, I haven't. Now I'm going to show you. It's really not hard at all. I'm going to show you one thing and you're going to go, oh, that's really easy. Okay, so you ready? I'm going to blow your mind with how easy it is. All right, you ready? So you're just going to be like, oh my gosh, that's the easiest thing ever. Okay. So, you ready?
Yes.
Are you ready?
Yes.
You ready? Sure. So you don't want me to clean your brains off the ceiling, right? Jonathan is going to be like no brains up. Okay. So we're going to end up with 2 and 5/6 divided by, I'm going to go ahead and I'm going to do 3. Okay. So, wait. When we divide by a fraction, you multiply by what they call the reciprocal. You flip it. Reciprocal. Reciprocal. So, can you multiply a mixed fraction by a fraction? Oh, high five across the room. Ready? You have to turn this into an improper fraction. Oh,
Is your phone?
I have 2 2/3 of a yard going to feet. Am I going small to big or big to small? Which one am I doing? I've got a yard and I'm going to feet. Which one's bigger? Which one's bigger? Yard. So I'm going from a big unit to a small unit. So you should multiply. Big, small, multiply. So 1 yard, and I'm turning that into 3 feet. They're together, so I need to multiply. Can I multiply that? You can. We just wrote that down. You can multiply mixed fractions and a whole number. The only thing you can't do is divide mixed fraction and a whole number. So go ahead and try to multiply that. Don't try. 2 2/3 times 3. 3 times 2, 6. 3 times 2, 6/3. 6/3 is improper. So that makes 2. 6 plus 2, 8. So you ended up with 6 6/3. 3 times 2, 3 times 2. So you have 6 6/3. This becomes 2. 6 plus 2 is 8. What?
So is that two the whole number for 2/3?
From 6/3. Because it's 3 times 2, 3 times 2. When you multiply a mixed fraction by a whole number, what?
I multiply the numerator and the denominator because when we multiply them like regularly, you do the denominator too.
Because if you made this an improper fraction, and it would be what, 8/3 times 3/1. That would be the only time you would ever do it. Because when you're doing it as a whole number, you leave the denominator alone. Not touch that denominator when you're multiplying it like this. 3 times the whole number, 3 times the numerator, leave the denominator alone. Okay? pints to cups. Big to small or small to big. Look at my little gallon thingy. Cups, pints, cups. It takes 2 cups to make 1 pint.
Okay.
So 1 pint is 2 cups. So 5.5 times 2.
Okay.
Because, well, hold on. Because it's 2 times 5 is 10. 2 times 1 is 2. Leave the 2 alone. So you have 10 and 2 halves. But you should have, right? If you multiplied it. 2 halves. What is that?
1 whole.
1 whole. So you can't leave that. You should change that to a 1. 10 plus 1 is 11. So if you end up with an improper fraction, you need to deal with it. If you end up with something that's equal to 1, you need to deal with it. You need to have a final answer. So you were halfway there, just not all the way there. Half a cup equaling pints. Am I going big? I'm going small to big. So over here, a pint is equal to 2 cups. So what I've started to do, if you notice, I've started writing like the conversion underneath it. See, I've got my fraction over here. What I was noticing is every time my fraction and my conversion, if they were together on the same side, I knew that I had to multiply. If they're on opposite sides of the equal sign, then I know I have to divide. They're on opposite sides, I'm going to have to divide. So that's something that maybe you want to take note of, because all the other times they were together. This time they're not. So this time I know I'm going to have to divide. A cup is smaller than a pint. It takes 2 cups to make a pint. I'm going to have to divide. So when I have 1 half, and I'm going to have to divide it by 2. Well, it's technically 2 over 1. I don't leave it like this. I'm going to have to change the sign and do what to the back? Flip it. Flip it like a pancake. Bam. Just go flat. Now, multiply it. So, if I only have half a cup, how much of a pint is that? How much is it? 1/4. It's 1/4 of a pint. And I mean, if you really think about it, it does make sense. It's kind of weird when you think about it number-wise, but if you have, let's see, a pint, and a pint is made up of 2 cups. This is a cup, this is a cup. And you only have half of a cup. Isn't that only 1/4 of a pint? If this whole thing right here is 1 pint, it's only 1/4 of a pint. Visually, if you're looking at it, it makes sense. Number-wise, you're like, that's weird. But if you look at the picture, it makes more sense to me. It looks weird number-wise, but picture sense, it's like, oh, okay. So, if my numbers are on the same side, multiply. If my numbers are on both sides of the equal sign, divide. Then you bring it to the other side, flip it, multiply. That's all you gotta do. Yeah. Wow. Okay. So, are you making a scale of your face? Okay, so yesterday we did a lesson where we took 3/4 and we multiplied it by 2/2, and we got 6/8. Do you recall? I hope so. Okay. If I have, okay, I want you to write these down. So this is A, and we have B, and we have C. This is not, this is a little thing. I don't know what to do. Remember, this is like over 1, over 1, over 1. These are not mixed fractions. But I remember teaching this, and some of you got it, and I said, if you get it, great, and if not, don't worry about it. Daniel, your binder should not be out unless you get a piece of paper. Okay. Because you're using valuable time for something that you should be writing. If I were doing 2/3 times 15, and look up here, I'm teaching you a strategy. If I look, this is like a cross simplifying thing. I've taught you this. I've done it. Can 3 go into 15? Yes. So, or if they share something that can make the numbers smaller. So 3 can go into 3 once. 3 can go into 15 5 times. So I can go like, I didn't teach it. Oh, I've taught it, and some of y'all were like, oh, yeah, I get it. And I said, if you don't get it, don't do it. But you can simplify, not multiply. It's like a division. Simplify. If they share a number crossways, that you can divide to make them smaller, because sometimes the numbers are very large. It's not raining anymore. And so that way I just end up with 10. That way I'm not having 30 over 3 that I have to divide. Not wrong either way. So if I had like 2, I don't know, 15 times 25. Well, I don't want to divide that. I don't want to multiply that or divide that. Well, 15 can't go into 25, but do they share a number? 15 and 25, do they share a number?
Yes.
What? A number that can go into 15 and 25. 5. So this can go down to 3, because 5 goes into 15 3 times. 5 goes into 25 5 times. So now it's 10/3. It's just smaller, easier to work with. So you don't have to do that. It just makes those numbers a little bit easier to work with. But whatever you were doing, I don't know what you were doing. Okay. So 4 can go into 4, you get 1. 4 can go into 12, you get 3. You don't have to do this. You could just multiply it across. So here you get 12. If you had done it the other way, you would have had 48 over 4, but you can't leave it like that. It's improper. And you would have to divide it, and you would get 12. Either way, you still get it, but you cannot leave this. So how does this, when you have 4/4 times 12, how does your product compare to your first factor? They're the same. Why are they the same? Because why? Which is?
A whole times 12.
Because you multiply it by 1. So it stayed the same because you multiplied it by 1. So the product, let me get this out of my way. Okay, so let me see what else. So we got this. So the 4/4 times 12 was equal to 12. Because you multiply by 1. So when you multiply by 1, it's going to stay the same. Your first factor is going to stay the same. It's going to remain equal. And that happened to us yesterday. Okay? So here with 3/4 times 12, you should have got 9. Or if you did it the other way, you got 36 over 4, which if you divided that, you would have got 9. So with 3/4 times 12, if I were comparing this to my original first factor of 12, is 3/4 times 12. This ended up being equal to 9. So is it greater than, less than, or equal to 12? It's less than. So it's this. Okay? Now, do you know why? Because, I mean, I still have 12, I still have 12, I still have 12. Do you know, I don't want to say understand because we haven't really discussed it. Do you know why this time, there's a precise reason why this time we ended up with our product being less than 12. When we started off with 12, we ended up with something less than 12. Why? Is the Lord the only person who understood it? Daniel?
Because the number was smaller.
Then?
No, because the number was smaller than the denominator.
What number?
3.
3. Because this fraction right here was less than 1. Any fraction that I put here, if it's less than 1 whole, my end product is always going to be lower. So this is less because the fraction, or the what they call the scaling. Oh, it's got a name. I can't find it on here. Right now we're gonna call it the fraction, but it's the scale. It's called the scaling something or other. The scaling something is less than 1, because this is less than 1. Your product will always be less than 1. It could be 99 out of 100 and it would still be less than, it would still be lower. It could be 999,999 out of 100,000 and your product will still be lower if it's less than 1. If your numerator is smaller than your denominator, they have to be the same for it to count, for it to be equal. They have to be exactly the same. Very good. Okay, so here, 1, 3, you ended up with 15. So if I have, you would have had 60 divided by 4, dividing that, you ended up with 15 anyway. So this is when doing this was really nice. So 5/4 times 12. The product of this was 15. Is it greater than, less than, or equal to 12? It's what?
Greater.
Greater. It's greater than 12. Why is it greater than 12? Do you know, Daniel? If you know, that'd be awesome.
The top number was bigger than the bottom.
Yes! High five across the room, Daniel. Wow! Yay! Okay. So because this fraction right here is bigger than 1, this is an improper fraction. It's 1 and 1/4. It could be 101 over 100, 3/2. Anything that would be improper times a number, you're going to end up with a larger product. Doesn't matter. So because scaling factor, that's what it's called. Because, there we go. I couldn't remember it. It was here. Okay, because I don't know if it's being used today, but it will be used. So maybe it's good to start using it, because the scaling factor, which is basically the fraction. It just determines the size of the product. That's all. It determines the size of this. So you have scaling factor, first factor, product. The scaling factor was greater than 1. So because this is bigger than 1, this was bigger than 12. Oh. I know, brilliant. So this goes against one of that one problem yesterday where the guy said anytime you multiply a number by a fraction, always is smaller. Really? Is it always smaller?
No.
No. Is it always smaller? No, because sometimes it's equal, sometimes it's bigger. I know you weren't here yesterday. Yes. So, yes, sometimes it is smaller, but sometimes it's bigger, sometimes it's equal. So, now this is when you're having to write those expressions. We did that a while back. It's been a little while since we did this. And so it's like we started doing something and then we did the shapes and then we're having to come back to what we were doing. So it's been a couple weeks. So I know y'all are probably like, How do I do this again? What? So half as long as 8 meters. So how would I write half as long as 8 meters? How could I figure that out? Half as long as 8 meters. How would I write that?
You could do 8 divided by
Okay, 8 divided by 2. But I could also do using that 1/2. Just like that, which would technically still be 8 divided by 2. Okay, so it says circle the scaling factor. Which one of these two numbers is the scaling factor? And it says put a box around the number of meters. So which one gets the circle and which one gets the square? Which one gets the circle?
1/2.
So 1/2 gets the circle, and what gets the square?
8 meters.
8. So can you tell me how many meters there are? Can you solve it and tell me how many meters there are? Go ahead and solve it. What? And then 8 times as long as 1/2 meter. So how would you write that?
Divided 1 meter is
You're not doing a conversion. How would you write the expression?
8. What?
How would you write the number sentence? Don't look over there. We're not doing a conversion. 8 times as long as 1/2 meter. Thank you. I'm like, what are you doing? 8 times 1/2. So which one is the scaling factor? Which one gets the circle? Which one gets the square?
The 8 gets the square. And the 1/2 is the circle. Wait, no.
This one gets the circle.
And then that is the square.
This one gets the square. Would I still get the same answer?
Yes.
Because you still multiply across. So 8 times 1, 8. 2 times 1, 2. 4. Okay, I'm not worried. I'm not going to worry about number 2. Okay, can you fill in the blank with a numerator or denominator to make A, B, and C true? Now, some of these, you're going to have a little bit of leeway as to what you write in there because there's not, on some of them, there's not an exact answer. So if you need to discuss this with the people in your group, that's fine. So we have 7 times something needing to be less than the original, the first factor. So we need 7 to end up being less than 7. So what numerator would I need to be in that fraction? So I could do a 3. Is 3 the only answer?
No.
No. What else could I use?
2 and 1.
I could do a 2. I could do a 1. So it needs to be anything less than 4. I cannot use 4, but I could do a 1, a 2, or a 3. I can't use anything else. Okay? What about 7 over something times 15, which is my factor, my first factor, needing to be greater than 15. I need 15 to get bigger than 15. So what can be in my fraction? Daniel. So I can use a 6, a 5, 4, 3, 2, 1. Anything smaller than 7, because it needs to be an improper fraction. I need 15 to get bigger than 15. And in order for that to happen, I need my fraction to be improper. Very good. Okay. 3 times something to be equal to 3, Antonio. I'm using 5. Can it be anything else?
No.
No, it cannot be anything else. Okay.